we do not have a ton left from sections 5.5 and 5.6. In fact, we have two, I guess you'd call them word problems because, yeah, they're written with words in them, but it's really just following along with what we've been doing, which is finding all the zeros, you know. So the first thing I wanted to do, because I had a couple of questions about this last week, some people that haven't had to use the TI-84 Plus on the app before, and I wanted to make sure everybody knew the easy way to find it. Right up here you see a button that says Dashboard when you get into Rapid Identity. And choose Applications, because this is an app we're talking about. And then, so that you don't have to scroll through all of them, hit grades 9 through 12. And that'll make it so you don't have to go through all of them. But then you have to scroll for a while because it is called the TI-84, so T is quite a ways down. And it's way down here in the bottom on my screen, and I can't use it because I already have the software on my smart board, but that's where you would hit, is right there for the TI-84 Plus calculator app, because we're going to need that again today. Haven. Oh, I bet you that would go super fast. Excellent. Yeah, Haven says just type TI in here, and that'll go super fast as well. So however you can get to it, because you need it. So again, today, if we had a third objective for this section, it would be applications. And it's an application, but I don't know that it's really like a real life application. So here's what we have to do today. We have two kind of word problems to look at. And problem 7 says the product of 3 consecutive integers is 3,360. Now, if you're writing this because you don't have the packet, you probably want to write that sentence down right there. Because those are really the instructions. You know, the rest of it you could see from your work. So problem 7, the product of 3 consecutive integers is 3,360. Now, what we're going to have to do is exactly what it says, which is write the polynomial equation in factored form, show that first, then solve for the numbers, and then we're going to just quickly verify it synthetically that we found the right answer. I'm going to give everybody a chance to write that down who didn't have a note packet. And that's going to be the start of second semester for everybody. We will be without the note packets. Unless you print them out. I mean, I always make mine available. I'm sure Mrs. Peterson and Mr. Michener do as well. All right, you ready? What does product mean? Getting an answer when you do what? Not adding. Multiplying. So, we have some stuff we have to do by multiplying, and it says 3 consecutive integers. Now, we actually talked about this when we took the 5.1 to 5.3 test. And I said, don't overthink it. Consecutive just means one right after another. Integers mean no decimals, no fractions. So numbers like 1, 2, and 3, those are consecutive integers. But we don't know what these consecutive integers are. So I would make the first one x. And then I'd think, okay, if the next one has to be in order, like 1, 2, and 3, what's something easy you could do to 1 to get 2? Add 1, right? Yeah. So x plus 1. Something really basic and easy you could do to 1 to get a 3, which would bring it to a total of 2. So this is going to be our first number, our second number, and I'm just using the, I know you guys will know it as hashtag, but it's the number symbol, and the third number. Now we said product means multiply, so x times x plus 1 times x plus 2 was supposed to be what? And you know that's going to happen, especially as the numbers get bigger. We're going to see bigger and bigger values for that product. So the first part of this was do this. Write it in factored form. Done. Now, solve for the numbers. Well, if I want to put it in the calculator, and I'm going to have to verify it synthetically anyway, I would want to multiply that out and see what it is. So I would do FOIL on these two little buggers right here. So x, the quantity x plus 1 times the quantity x plus 2. First times first is x squared. Outside times outside plus 2x. Inside times inside plus 1x for a total of 3x. Last times last plus 2. And then I distribute the x, which basically just means increase the power of x by 1. And now if we want to put that into the calculator too, here's the big word up here, solve. What's wrong with that? Why wouldn't we put it in exactly like that? Google Meet, folks, you can help out too. Why wouldn't we put that in exactly as it is?
Because you'd want to multiply the x with the x plus 1.
Oh, you could do that. To me, it's easier to do the FOIL and then distribute the x. But I'm talking about this last line right here. There's something there that doesn't make that good for punching it in as it is.
It's not equal to 0.
Exactly. Let's subtract 3360 from both sides. Yeah, whenever they say solve, solving is finding the zeros. Now, I don't know about you, but I wouldn't look forward to factoring that. 3,360, whew, there's a whole lot of numbers that go into that big thing. And actually, if we tried to factor this by grouping, because it has 4 terms, we wouldn't be able to. So we do turn it over to the calculator. So, oops, I put a 2 for a 3 right there. Do that every once in a while. There it is. X cubed plus 3x squared. Let's see if I can get it so I can still see it while I'm punching it in. So y equals x to the third plus 3x squared plus 2x minus a whopping 3,360. Then because we're turning this over to the calculator to get the answer, we've got to be so careful that we punched it in right. So always just stop and pause for a second or two and see if you have it in there. Now here's the great thing about these numbers. They're integers. Because they're integers, they're going to show up in our table. So we're not going to have to use Blinky at all for this. We can go into the table until we see a 0 for the y. And then, like I said, we're going to check it anyway. But everybody have it in? So second graph, and we're going to keep scrolling down. We can see the numbers in the y are getting smaller. Oh, there it was, right there. So 14 is the smallest of the 3 numbers because it gave us a 0. If my blue marker will work, there it goes, right there. So that's the smallest of the 3. So let's go back and figure out the other 2. So if the first one's 14, what's the second one? They have to be in a row. 15. And what will the last one be? 16. Now, I didn't leave myself enough room here because it says we're supposed to verify our answers synthetically. Luckily for me, I can kind of cheat and move this down. Oh, behave. Let me see the bar. There we go. Now, if you're thinking, how are we going to check all three? We're not going to check all three. We're only going to check x, and x was 14. So we already know that we have our equation in standard form. Everything's on one side. 1x cubed, 3x squared, 2x, negative 3,360. And yeah, these are bigger numbers, so you might have to use a calculator for your synthetic this time. But how do we start again? Do you remember from last week? Bring down that 1, that leading coefficient. Multiply outside the box and move it inside the box. Add. And like I said, you might want to grab a calculator at this point. I think it'll just save a little bit of time. So 17 times 14 is, glasses, 238. So we add and we get 240. And now here's the good news. We know we're supposed to take 240 times 14, and we had better get 3,360 or we mess something up. And we do. So this part is just checking our answer. You know, we're checking to make sure that our equation was right and that 14, which is what we saw from the graphing calculator, actually works in our equation. Now, we don't want people to just sit there on this question if it's on the test and do 11 times 12 times 13, 12 times 13 times 14. It actually goes faster, you know, when you develop this, and I have to see your math anyway. So make sure that you're setting it up. It'll go much faster. Alrighty, now let's switch the number this time. So again, if you don't have a packet, write that down. The product of 3 consecutive integers is 9,240. Don't need the rest of the directions because we're going to show all that work down below here. The product of 3 consecutive integers is 9,240. We ready to start? Alrighty. So what do you suppose we should use for the smallest number? X, smallest number. How about the next number? X plus 1. And the third number? X plus 2, exactly. Now what are we supposed to do with those 3? Put them together. How? Goes back to product. Write it in factored form because product means? Yeah. Well, at this point, you're probably saying, isn't the left side going to be exactly what we just had for the other one? Uh-huh. But let's show those steps again. Now, there was an important thing we had to do this before we punched it in. Do you remember the important thing? Make it equal to 0. Subtract 9240 from both sides. All right, I got the x to the third on that one this time. Do we expect these numbers to be bigger or smaller than the other problem that we did? Got to be bigger, right? because our original 3 multiplied to 3360. This multiplies to 9240. So again, let me see if I can get that down there so I can see it. And there's our x cubed plus 3x squared plus 2x. I really just have to change the 3360 to 9240. You guys are punching and you're done already? You found it already, right? Yeah, because it takes me a while to get these all punched in. The smallest number is 20. Yeah, there's our 0. So 20, and what are the other two? 21 and 22. But we have to check it synthetically. Not all 3 of them. What's the only one we check? Yeah, the 20, the one that we found on the calculator. So again, you bring down your leading coefficient. Outside the box, multiply by A. Inside the box, add. Outside the box, multiply by A. Inside the box, add. And then, yeah, if we did it right, we already know what 462 times 20 is. It's going to be 9240. But just grabbing my handheld here to make sure. Yeah. Oops, put it in the wrong spot, though. And there it is. So we start in factored form, but we do the math so that we can put it in standard form, because we're going to need that later to check our answer and see if everything's there. So when they say 3 consecutive integers, what can we always use for the variables? X, x plus 1, x plus 2. There we go. X plus 1, and x plus 2. That's everything. That's from 5.5 and 5.6. So the rest of this time will be work time. And notice I had to add a problem in here because the book didn't have a good, find 3 consecutive integers problem on there. So doing a few from the 5.5, a few from the 5.6, and then maybe you want to do the consecutive integers one right away, because I know here in the classroom it was boom, 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 people have it. So you might want to get that one out of the way before you open up your book. But that is it for today. And then the next 2 days we'll be doing the practice test and reviewing. And Thursday we'll take the test.
Okay, seems to go.
Yeah, have a great day.
You too.
Thank you. All right, let me hit the lights for all of you. Let's see what you're doing. Again, if you have a question, Google Meet, folks, stay on. Or you can work. Yeah, what's up, Neil?
Can you go back to the got it? I didn't finish writing everything down.
Oh, yes, give me 1 second.
Okay, thanks.
Got some people here that are still writing these down, and then I'll flip it back. Why don't I ask you guys to hang on a second, and I'll put it back up here and then leave it up there. Sorry, Neil, I went too fast, huh?
I was just too slow.
Well, I guess that's a different way to look at it. Okay, should I scroll it up or down, or is that right where you needed it?
That's good, thank you.
Yeah, you're welcome.
Alright, see you later on.
Have a good one.
Yeah, you too.
Thank you. Okay, and now I can put this up higher for you guys so you can see it a little better too. Yes. What